For question 36, so it is easier to solve by assuming that the resistance of the lamp when cold, that means when no voltage is applied, we let it be around 100 ohms. So this is 100 ohms and this is 100 ohms. So this is still open. So when we apply a potential difference across it, so both of them have the same resistance because it's identical. So they will consume the same potential difference shared equally between both of them to give us to bright up normally. When S is closed, so this is also another 100 ohms. So the effective resistance from the parallel connection will result in the resistance being reduced. So in this case becomes 50 ohms. So the L1 is still at 100 ohms. This is when it is cold. Alright, so when a PD is applied across it, this will now take up more voltage, a more potential drop than this one. So it will be even more than the previous case, so that this will light up brighter now, and this will have less potential difference, and therefore L2 will be dimmer now. Right? So the answer is B. For 37, we find the effective resistance for the parallel connections. So 100 and 100, so it will give us 50 kilo ohms. And now we see what is the PD dropped across the parallel connection. So if this is 50, so 50 over the total, 100 plus 50 multiplied by the 6 volts from the power supply. So this will give 2 volt. So the potential drop is 2 volt across the parallel. So using V equals to IR. So for the R2 resistor, R is 100,000. So therefore, we can calculate I, and it will be 20 microampere. Question 38. So isotopes, we know that, let's say this is an isotope with 8 protons, and this is another isotope. It have the same number of protons, but different number of neutrons. So if I just call this 9 neutrons and this as 10 neutrons, so the mass of this is larger. So the nucleon number will be, so the nucleon, the same number of neutrons, so this is out. The nucleon number is the total of both of them, so this is 17, this is 18, so the C is also out. And if you look at A, the nuclei each have the same acceleration in the same electric field. So if we let both of them in a particular electric field, so because they have the same number of protons, the same positive charge, so they will experience the same electrical force, E equals to F equals to EQ. Okay, this is constant, this is constant because 8 protons, both also same, so they have the constant force. So force is also equals to MA. So for the one with a greater mass, which is the 10 neutrons, it will have a smaller acceleration. So they will have a different acceleration, not the same acceleration. And uncharged atoms. So if now we consider the whole nucleus with the electrons surrounding it. Uncharged means it's not ionized, so the charge is 0. So there must be 8 electrons as well. So for this, also the same. Uncharged means we must also have 8 electrons. So it's not ionized yet. So it's the same number of electrons. Question 39. So the number of protons on the left hand side of the equation must equal the number of protons on the right hand side. So if this is 16 plus 42, if we subtract 2, you get 56 here. And the total number of nucleons must also balance on the left and the right hand side. So 32 plus 94, if we minus 4 over here, you get 122. And for quark composition for a neutron, we know it is up, down, down. Therefore, anti-neutron is just having the opposite quark. So it's an up bar, and down bar.